All right, welcome to day 6. We got page 43 and 44 for homework tonight. Go ahead, pause the video, give the warm-up a try, and when you're done, you can hit play and see the warm-up gone over. So we got triangle ABC is similar to triangle DEF. Make sure when you're labeling it, you have A and D, corresponding spots B and E, C and F, because that's what we're trying to see if they're similar or not. So AB was 3, AC was 8. FD was 24, DE was 9, and we had A congruent to D. And we want to know if they're similar or not. So really the only option for us to try is side angle side similarity theorem, because we got an angle between two sets of sides. So let's look at our ratios. So the 3 matches with the 9, which reduces to 1/3. The 8 matches with the 24, which also reduces to 1/3. So we got two sets of sides that are proportional. We got a set of congruent angles in between. So yes, by side angle side similarity theorem. Going over to the homework, we got our original A and B. We wanted a dilation of 3 from that was centered at -2, 1. So plot A and B, connect them, plot -2, 1. So A is 1 to the right and 3 down, so we want 3 times that. So you got to go 3 to the right and 9 down to get A prime. B is 4 to the right and 3 up. So do 3 times that, and we want to go 12 to the right and 9 up, and that gives us B prime. Connect them, and you've got your image. So why are the triangles similar? Well, you've got parallel lines, so you have congruent corresponding angles. You've also got reflexive there as well. So by angle-angle similarity postulate, the triangles are similar. So we can set up a proportion. So x in the small triangle matches x plus 7.5 in the large. 12 in the small matches 18 in the large. Cross multiply and solve, you got x is 15, and that's what they wanted us to solve for. Similarity ratio is 3 to 5. We're working with areas, so we got to square those similarity ratios. Cross multiply and solve, you get that x is 63. And that is an area, so our units on there should be meters squared. So remember, if the center of dilation is on the line, it's the same line. If it's not on the line, it's a parallel line. Well, our y-intercept of that line is -4. It's not 0, 0, so we know 0, 0 is not on the line. So your y-intercept there of 0, -4 is going to be 6 times as far away from the origin, so now it's -24. And that gives us our line that is parallel that's created by the transformation. 1 times 4 gives us 4, -2 times 4 gives us -8. So our scale factor was 4. In 12a, we've got a reflexive there. And in both cases, you have 8 over 18 for small triangle to big triangle, which reduces to 4/9. So they are similar by side angle side similarity theorem. Here we don't have any angles, so we're just checking our sides. 60 over 40 does match up. Now, to make sure we're matching up correctly, notice this is small, medium, and large, and here's small, medium, and large. So you got to make sure you match with the smalls, mediums with mediums, larges with largest. So that's why we have 60 over 40 to give us 3 halves. We have 45 over 30 to give us 3 halves. But then 32 over 22 is 16/11. So that one's doesn't match the others. So the sides are not proportional. So those are not similar. So if you put the 0.45 in, it checks out. So our transformation is just the exact same line. So your area ratio is 27 over 48, which reduces to 9/16. So that's our similarity ratio squared. So you got to take the square root of each of them to find the similarity ratio, which will be the same as the ratio of the perimeter. So 3/4. So the angle of the sun is the same for both of them. So we got 56 degrees. You got a right angle, so we know they're similar by angle similarity postulate. Then set up your proportion and cross multiply. We get 13.5 feet for the cactus height. All right, we're going to be on page 40 to start our day 6 notes, and we're going to look at proofs of similar triangles today. In proofs of similar triangles, of our 3 things that tell us whether things are similar or not, we use the angle similarity postulate. So that's the only one we use within proofs. So our goal to get triangles similar is just to get 2 pairs of angles congruent. So take a moment to do your statements, reasons, and givens. And we only have 2 triangles there, so it's pretty clear the ones we're getting similar, and they tell us in the question. So we've got parallel lines, and we've got some zigzags there. So we want to do parallel lines, implies congruent, alternate, interior angles. So with our zigzag going that way, we have A and E. With our zigzag going the other way, we have B and D. Well, we've got 2 sets of angles, so we have what we need. So we can now say the triangles are similar. And our reason is our angle similarity postulate. So that's the only one of our similar reasons that we'll use within proofs. Now, I just want to point out, we could have also done here just 1 set of congruent alternate interior angles and then done 1 pair of vertical angles, and that would be fine as well, but it would have been a little bit more work. So go down to the bottom, take a moment to your statements, reasons, and givens. So the ones we're trying to get are AEC, which is this one, and we want CDB, which is this one here. And that second given there, they told us we had right angles, so let's just go right ahead and we'll do right angles implies congruent angles. And that'll give us angle 1 and angle 2 congruent. And that already gives us one set of angles. Well, the other given we have is an isosceles triangle. Isosceles triangle can imply two congruent sides or two congruent base angles. The one that will help us here is our two congruent base angles. So we need the whole big angles on each side of the base. If AC is the base, we need the big angles on at A and the big angle at C. So we can call the one at A just angle A because that's the only angle there. But the one over at C, we can't number and we can't use a single letter because there's so many angles going on there. So we got to use three letters. So we'll call it angle BCD. Well, that now gives us two sets of angles congruent. So we can now say the triangles are similar. Make sure when you're saying similar, you don't do the congruent symbol by accident. Just do the one squiggly. And our reason, we've got the angle similarity postulate. So these last two are our basic similar triangle proofs. Kind of like with congruent triangles, we'll often take it beyond that step. So our next step after we prove triangles similar is using the fact that similar triangles have proportional sides. So this is the reason we will use similar triangles imply proportional sides. And notice in number 3, our prove is we want sides to be proportional. So when you see something like that as your proof, it needs to click in your head, oh, this is just a similar triangle proof, which I can get from angle. And then I'll go one extra step to say similar triangles imply proportional sides. So let's start out with our statements and reasons and do our one given. So this particular picture only has two triangles. So it's kind of obvious which two we want to get similar. We'll see some that become a little bit trickier when there's more than just two triangles in the picture, and we'll see those coming up. But for right now, we know it's that top triangle and the bottom triangle we're trying to get similar. Well, this is pretty similar to the problem we did 2 questions ago. We can do parallel lines implies congruent alternate interior angles. So one of our zigzags will give us B and C. The other zigzag will give us A and D. Well, now we have two sets of angles, so we can do our angle angle similarity postulate, just like we did on the last two questions. We got to be a little bit more careful about naming our similarity statement for the triangles. So I'm going to start with CDE is similar to triangle, and we got to make sure they match up. C was our alternate interior with 1 mark, that matches with B. D was our alternate interior with 2 marks, that matches with A, and then that goes to E. And now, because we have similar triangles, we can do our new step that is started up above. We're going to do similar triangles, imply proportional sides. And our statement is just the proportion that they wanted for our prove. So we got AE over DE is equal to BE over CE. So if you see a proportion as your prove, you want to think in your head, okay, this is just a similar triangle proof where I'll get 2 sets of angles congruent, and then I'll go one extra step, I'll do the similar triangles implies proportional sides. Go ahead, get your statements, reasons, and givens down in 4. So this picture has 3 triangles, so we got to be a little bit more careful about which triangles we're trying to get similar. And what you do is you go through your list of sides in your proportion until you find one that is only part of one triangle. So let's start with DC. DC is only a side in DCF. So that's good. If it was in multiple sides, we would move on until we found a side that was only in one triangle. So of the other 3 sides, we need to find another one that's in DCF. Well, that would be DF. So this is one triangle we want to get similar. And then the other 2 sides should make up the other triangle we want to get similar. We've got EB and EF. So that's this triangle here. So those are the 2 that we want to get similar, meaning we want to try and get 2 sets of angles congruent in them. Notice they told us parallelogram. Well, we have that a parallelogram implies opposite sides parallel. We have 2 sets of opposite sides parallel, but the ones we'll want for our zigzag, we'll want DC parallel to, and you can name it because they told us it's just an extension, we'll actually call it AE, because B to E is just extending the side in the parallelogram. And from there, we can then do like we've seen in several others, that our parallel lines implies congruent alternate interior angles. And I'm just going to go ahead and number them just to make life a little easier. So 1 is congruent to 2 from that zigzag. And 3 will be congruent to 4 from the other zigzag. Well, we can now do our similar triangles. So we'll have the angle-angle similarity postulate. And for our statements, just name one of the triangles whatever you want. We'll go BFE, is similar to triangle. B was our alternate interior with 1 mark, so that matches with C. F was the one where our vertical angle was that we didn't use, so that's going to match with F. So we'll have CFD. And to finish it off, we'll have our new reason. Once you have similar triangles, you can say similar triangles implies proportional sides. And our statement is just what we wanted to prove. So moving on to number 5 on the next page, go ahead, get your statements, reasons, and givens down. Oops, this is all one given. So we've got 3 triangles in our picture. We've got to see which ones we are working with. So we have PR to start out. Well, luckily PR is only in one triangle. It is in PRS. Now, when I say PR is in a triangle, that means that complete side is in the triangle. That exact amount is a side in a triangle. So we got to find another side that is in that same triangle. PS is in that triangle as well. So this is one triangle we're working with. And then the other 2 should make up the other triangle. We got PS and PQ. So this is the other triangle that we're working with. Well, one thing that jumps out to me right away is notice angle P got traced. Angle P got traced twice, so we can do a reflexive property. And that'll give us angle P congruent to angle P. And we can use a single letter because that's the only angle that's happening there. And for other one, we're going to work with right angles eventually. So notice they told us PSR is a right triangle. Well, we're going to use something we usually don't use in this direction, but we're going to say right triangle implies right angle. And in triangle PSR, if the hypotenuse is PR, that means that angle PSR is right. So we don't mark anything in our picture because we haven't said anything's congruent, but we got PSR is right. But we also have an altitude. So we can do altitude of a triangle implies perpendicular lines. Our altitude was SQ, so we'll have SQ is perpendicular. They said that was drawn to hypotenuse PR, so SQ is perpendicular to PR. Then we've got perpendicular lines imply right angles. So we actually have two right angles we can get there on either side of Q, but we only need one of them. We need this one right here, so we'll say angle 1 is right. Because then we can do our right angles implies congruent angles. And that'll allow us to say that angle 1 is congruent to angle PSR. And we'll mark that up in our picture. There's the right angle, there's the right angle. Well, both our green and blue triangles have two sets of congruent angles. So we can now do our angle similarity postulate. For our similar triangles, the first one I'm going to name is PSQ. P was our reflexive, so that's got to match with the same one in the other one, P. S was in our green triangle was the one that had no marking, so that's got to match with R. And then Q was our right angle in the green, that matches with the right angle, which happened to S in the blue one. Well, to finish off, once we know triangles are similar, we can do similar triangles. It implies proportional sides. And our statement will just be what they wanted us to prove. PR over PS is equal to PS over PQ. So one last one for this video. Go ahead, do your statements and reasons and get your given down. And we've got three triangles in this picture, so we got to decide which ones we're trying to get similar. We'll start out with PT, see if it's only in a single triangle. If it is, that'll help us. If not, we'll just move on to another side until we find one that's only in a single triangle. So PT is only in triangle PTW. So it looks like that one's going to work. PW is another one that's in that triangle. So PTW is going to be 1. QR and QW must make up the other one. So those are our two triangles we're going to try and get similar. Well, we have a parallelogram. Let's do parallelogram implies opposite sides parallel. We've got two sets we can get parallel, but the ones we're going to want for the zigzag, we're going to want RQ to be parallel to its opposite side, and we can call it ST so that we can use the whole thing because it's an extension of the side. We got one zigzag going that way. We got another zigzag going this way. So we'll call them 1, 2, 3, and 4 to make life easier. And we'll have our parallel lines implies alternate interior angles congruent, giving us 1 congruent to 2, and angle 3 congruent to angle 4. Just like the other ones we've seen with this, you could have done a vertical angles. It just would have been an extra step, so this was a little quicker. We've got two sets of angles congruent, so let's do our angle similarity postulate. First triangle, let's call PTW, is similar to triangle. P was our alternate interior with 2 marks, so that matches with Q. T was our alternate interior with 1 mark, that matches with R, and then W was the third one. And then to finish this off, we've got our similar triangles, implies proportional sides. And our statement is just what we wanted to prove. That's it for this video. Have a great rest of your day.